Honors Algebra 2, Chapter 13, Section 6, last one of the chapter. We're going to look at law of cosines, and we're also going to look at Heron's area formula. So yesterday we talked about law of sines. We used law of sines for these possibilities. We're given the angle side, the angle side angle, or the side angle, and that's the given information when you use law of sines, because we have an angle and a side opposite. But if we are given a side angle side, or we're given the three sides, we have to use law of cosine. So this is where we use the law of cosine as if we're given this given information. So this is the law of cosines. You're given like side A, B, and C, then you can solve for cosine A. Or if you're given side B, C, an angle between that A, you can solve for side A. And so then for this example here, we're given side 11, side 14, and the angle between is 34. So then we can plug that in. We do not know side B, so I would use the one that says B squared equals the other two sides squared, so it's 11 squared plus 14 squared minus double the two sides, given sides, times the cosine of the angle between 34. And you just plug these values in. So this is going to be 121, 196 minus, that's 308 cosine 34. Well, that's b squared. So then we can square root both sides. We have to evaluate everything underneath it first. So b is going to be, and that's how I punch it in. You get approximately 7.852. So that would be the side. Now that we have that side, we have an angle and the side opposite. So we could keep using the law of cosines, or a little quicker is to use law of sines. So I could use like the sine of 34 over the side we just found, the 7.852. And I can set that up as the ratio or proportion of the sine of side or angle A over 11, and I can cross multiply and solve for A. I can do that similarly for angle C. Here's the second one. Here's where we're given side, side, side. And this one's a little more difficult. The reason why is when we're given these angles, we have to be careful how we solve this. If we use the law of cosines the entire problem, we can solve it, we get the answer with no issues. But the more efficient way of solving the problem is to use law of cosine the first time, then use law of sines after that. And the reason why this problem becomes difficult because if you use law of cosine first, and then you use law of sines, you can actually create the ambiguous case. So to make sure that does not happen, we always find the biggest angle first using law of cosine. So you always want to find the largest angle first, because we can only have one obtuse angle. Law of cosine will not give us the ambiguous case. The reason why, if you think about a triangle's angle is between 0 and 180. Each angle of a triangle has to be between 0 and 180. It can't be even bigger than that. So cosine is the x value. Cosine goes from 1 to -1 is the x values for all the points between 0 and 180 degrees. So there's no repeat points. You can't have two triangles to describe one point. If we're looking at the sines though, sine between 0 and 180, we have multiple triangles, an infinite amount of triangles that are the same exact triangle in two different spots, one in each quadrant. And so sine creates the two possible triangles. And so if you think of kind of compare it back to the unit circle, sine creates two possible triangles, where cosine will never do that. So that's kind of unique about law of cosines. So for this one, we want to find the largest angle first. So to do that, we look at our three sides. You find the largest side. So let's find this angle first. So then side of 27 squared is going to equal 12 squared plus 20 squared minus double 12 times 20 times the cosine of our angle B, which we do not know yet. So I can go through and solve this. So this is going to be 27 squared minus the 12 squared, or 144, and minus the 420 squared. And then we're going to divide the whole thing by the portion we're multiplying cosine by. So then divide by negative 2 times 12 times 20. And that's going to equal the cosine of B. So then we want to find the inverse cosine of this mess. So we want to do the inverse cosine of the answer we get from all of that, and that'll be the angle B. And so we find that B is 112.67 degrees. Now that we have that, we know that's an obtuse angle. The other two have to be acute angles, so there's no possibility to have a second triangle if we use the law of sines. So I can do sine of angle B over the 27, and that's going to equal the sine of A over 12, and equal to the sine of C over 20. And I can just cross multiply to solve for those unknowns. So Heron's area formula is another way to find the area of a triangle, and this is when you're given the three sides of the triangle. So to find the area, it's the square root of s times s minus a times s minus b times s minus c, where s is what's called the semi-perimeter. It's half the perimeter of that triangle. So if you're given this triangle, it's kind of an area within the city. We can find the area by just first finding s. It's 1/2 times quantity of 170 plus 350 plus 240. And so if you do that, you find that the semi-perimeter would be 380. And so I can plug that into the formula. So the area is going to be the square root of 380 times 380 minus 170 times 380 minus 350 times 380 minus 240. So the square root of 223,440,000. So you take the square root of the answer, you find an area that's equal to 14,947.9 square yards. You get the area of that region. So that's the second way of finding area of triangles, where yesterday it was a little different. We had two sides and an angle between. This one you have three sides on how to find area. So that's it for chapter 13. See you tomorrow.